So this is your given question. Now what we are going to do here is, you see that you don't have any denominator here, right? So what we are going to do is, for the first step, because we have x tends to infinity and because we don't have any denominator, we are going to take a denominator by dividing the numerator and denominator by x. Okay, so you have in the numerator, you have root over of x square plus x plus 1 minus root x square plus 1. We divide the numerator by x. And in the denominator, you have a 1, right? So you divide the denominator also by x. Okay. Now what you are going to do here is, you are going to take in the numerator, you're going to first separate minus okay. Now after separation, you see in the numerator you have x in the denominator, and you don't have that x within the radicals. Okay, so what you are going to do here is, you're going to take that x within the radical. So if I'm going to take, if you remember, I had told you this is a very important step, that if you are going to take this x within this radical, then this should become x square, right? So you must have x square here, right? So I've extended the radical from the numerator till the denominator. Are you facing any delay between my voice and writing?
Yes, sir.
Okay, by what time is it delaying approximately?
Sir, a lot.
5 seconds?
Yes, sir. 5 to 10 seconds.
10 seconds? Okay.
Yes, sir. Cannot see anything.
Okay. So just see the steps. If you are not able to understand any step, I'll go over it once again. Okay.
Okay, sir.
Besides, you will also have the recordings, so you can go through the recordings also later on. Now here in the numerator, what you do is you separate. Okay. So you have 1 plus x by x square will be 1 by x only, and 1 by x square. Root over of 1 plus 1 by x square. Okay. Now you see I have all 1 by x's in the numerator and denominator. Okay. So what I'm going to do is, I'm going to put y is equal to 1 by x. Okay. So therefore, as x tends to infinity, y tends to 0. Therefore, what does this limit become? If we change everything in terms of y, this becomes limit y tends to 0, root 1 plus y plus y square minus root 1 plus y square divided by y. Okay, I'm going a little slow so that to make up for the delay, okay, as much as I can. Now what you are going to do here is, you are going to rationalize the numerator, okay, by multiplying by the rationalizing factor. What is the rationalizing factor here? In this case, root 1 plus y square plus root 1 plus y square. This is the rationalizing factor. So you multiply the numerator and denominator by the rationalizing factor. Okay. Can you see both the steps in y that I have done till now, or is it still about to come? Still about to come?
No, sir.
So in the numerator, you have a square minus b square form. And you write the denominator as it is. Okay. We have 1 plus y square in the numerator minus 1 plus y square. Okay. Open the brackets in the numerator. And write the denominator as it is. So what have we got here? Now, if you look at the numerator, plus y square and minus y square cancels. Plus 1 and minus 1, they cancel. So you're left with only y in the numerator. And the denominator also, you have a y. Actually, they will also cancel. But we'll cancel this in the next step. So this cancels. Okay. Now, if I put y is equal to 0, will I get a determinate form? Just check. Will I get a determinate form?
Yes, sir.
Yes. Then I can put y is equal to 0. Let me just finish this step. In the next step, I'm going to put y is equal to 0 now. So you're getting 1 by root 1 plus root 1, which is half. And that solves your limit. Okay. Any question?
No, sir.
We move on to the next problem then. Okay, next question is number 4, 6 part 4. The question here is, limit x tends to infinity, x cube plus 6x square plus 1 by x to the power of 4 plus 3. Now you see here, this is a polynomial in the numerator as well as the denominator. What is this called? What is this function called? Can you tell me, Piyush, what is this function called?
Sir, exponential.
Not exponential. This is called a rational function, a rational polynomial function. Because you see all the coefficients, because you have a polynomial in the numerator and denominator. Also, what you see is that the coefficients of these are rational. So that is why it is called a rational polynomial function. Okay. Now, whenever you have a rational polynomial function, or in fact, if you have a rational function, even if you have a polynomial function in the numerator and denominator, the coefficients may not be rational. Even then, the technique in this is always remember that you will have to divide the numerator and denominator by the highest power of x. Okay, which is the highest power of x here? X to the power of 4, right? So you divide the numerator and denominator by x to the power of 4. Okay, at limit x tends to infinity, and then you have x cubed by x. If you separate, x cubed by x to the power of 4 will give you 1 by x, plus 6x square by x to the power of 4 will give you 6 by x square, and this will give you 1 by x to the power of 4 divided by, and in the denominator if you separate, you're going to get 1 plus 3 by x to the power of 4, right? So limit x tends to infinity, you have 1 by x here, you have 6 times 1 by x square, and you have 1 by x to the power of 4 divided by 1 plus 3 times 1 by x to the power of 4, right? So now we have got everything in terms of 1 by x. So what am I going to do? I'm going to put y is equal to 1 by x. Therefore, as x tends to infinity, y tends to 0. So therefore, what does this limit become? If I write everything in terms of y, x tends to infinity means y tends to 0. And you have y plus 6y square plus y to the power of 4 divided by 1 plus 3y to the power of 4. Right? Now, is this a determinate form? Piyush, is this a determinate form? Can you tell me? Can I put y is equal to 0 now? Can I put y is equal to 0?
Yes, sir.
Why?
Sir, because if you put y equal to 0, we will get, sir, 1, 1.
We'll get 0
Sir,
because
yes,
we are
sir,
not,
0 by 1.
because we are not getting denominator equal to 0. The limit can be equal to 0, no problem. But the only problem is that it should not be an indeterminate form. That is, the denominator cannot be equal to 0. So let's put y is equal to 0. 0 plus 6 into 0 square plus 0 to the power of 4. So you see that the denominator does not vanish, right? So you get here 0. So the value of this limit is 0. Okay. Last problem from this exercise. Number 5. Limit n tends to infinity, summation n cube divided by n to the power of 4. Now here, what I have forgot to mention is that n must be a natural number. Okay, so please make note of this. Okay, this is a very important step which I have forgotten to give you. In fact, any very important part of the question which I forgot to write. N must be a natural number. Clear with this? You can add it. Limit n tends to infinity. Summation n cube. What do you mean by summation? It is the addition of all n cubes. And what is n? First put n is equal to 1. You get 1 cube, then 2, then 3, and you continue this till n, right? And you have n to the power of 4 in the denominator. Okay. Now, do you know the sum of the cubes from AP? What is the sum of the cubes of the first 10 natural numbers? Anyone? Sum of the cubes of the first 10
And
natural
into,
numbers. Yes.
sir, 10 into 11
Huh?
by 2 whole
Whole
square
square. N into n plus 1.
by 2 whole square.
Yes. N into n plus 1 by 2 whole square. Divided by n to the power of 4. Okay. So this is limit n tends to infinity. Okay. So now in the numerator you have n square and you have n plus 1 square divided by 4 divided by n to the power of 4. Right? So limit n tends to infinity, n square into n plus 1 square, and you take 4 below. Okay. Now again, is this a rational polynomial function in n or not?
Yes, sir.
Yes. That means, and what is the highest power in the numerator?
4.
4, because n plus 1 square will give you the highest power 2, and you already have a product with n square. So the highest power in the numerator is 4. Also, the highest power in the denominator is 4. And what is the greatest of the two? It is 4, right? So you divide the numerator and denominator by n to the power of 4. So n square into n plus 1 square by n to the power of 4 divided by 4 n to the power of 4 divided by n to the power of 4. Okay. So now in the numerator, what happens? First of all, n square cancels from here and this power cancels to 2. And you simply have a 4, right? So now you have limit n tends to infinity. You can write this as n plus 1 whole square divided by 4n square, right? Now again a rational polynomial function, right? Highest power in the numerator is 2 and the highest power in denominator is also 2. So you divide numerator and denominator by n square. So n plus 1 square by n square divided by 4n square by n square, right? So what are you left with? Limit n tends to infinity. You have n plus 1 by n square, and the denominator you only left with 4, which is equal to limit. Now if you remember, this is a product with 1/4, right? Let's write this as limit n tends to infinity 1/4 of n plus 1 divided by n square. Now this 1/4 you can take out of the limit, because if you remember from the limit theorems, I told you limit of k into fx. You can take the k out of the limit, the constant out of this limit, right? K limit fx, right? Whatever the limit tends to, right? Isn't it? Let's say x tends to a, right? So I can take 1/4 out of the limit. One plus 1 by n square. Now I have everything in terms of 1 by n because n tends to infinity. So now I will say let m is equal to 1 by n. Therefore, as n tends to infinity, m tends to 0. Therefore, what does this limit become? 1/4 limit m tends to 0, 1 plus m square. Can I put m is equal to 0 now? It will give me a determinate form, right? If I put m is equal to 0. Yes, I can put m is equal to 0. So that means this is equal to 1/4. Any question on this problem? Okay, no question.
No, sir.
Okay, I'll move on to the next exercise then. Okay. In the next exercise, you have certain standard limits. Now, I'll tell you the meaning of these limits first. I am sure you have in the course of your vacations, you must have memorized these limits, right? So, what does this limit mean? If you see limit x tends to 0, sin x is equal to 0. What does this limit mean? This limit means that when x is very close to 0, sin x is also very close to 0. Understood? Similarly for cos x, if limit x tends to 0, cos x is equal to 1, that means when x is very close to 0, cos x is very close to 1, right? But what does this limit mean? Sin x by x is equal to 1. It means that when x is very close to 0, sin x by x is equal to 1, right? To 1. That is, if sin x is very close to 1, that means sin x by sin x is approximately equal to x. Clear with this? Did you understand what I mean by this? By
Yes,
saying
sir.
this? Yes. So sin x by x is equal to 1 means when x is very close to 0, sin x and x are almost equal to each other. Okay, the value of sin x and x are almost equal to each other. Similarly, you can say for limit x tends to 0, tan x by x also. Okay, so that is what these results mean. So after the interpretation, and I'm sure you have memorized these results also, we'll be using these results to solve certain problems. Okay, so we'll start with the first problem. Number 1. The given limit here is limit x tends to 0, 2 sine square 3x divided by x square. Okay, now look at this step very carefully, what I'm going to do, because later on certain steps I'm going to skip because they'll appear very trivial, okay, compared to the length of the sum. So observe the crucial steps and in these introductory sums. Okay, so what I'm going to do is, first of all, 2 is a constant, so I'm going to take it out of the limit. I'm going to write this as 2 limit x tends to 0 sine square 3x divided by x square. Now we want to bring this limit to this form, this one. Okay, so what we are going to do here is, let me write here, twice limit x tends to 0. I am going to write this as sine 3x square, right? And below, what I'm going to do is I'm going to take a 9x square. Or better write this as, because see I have sine square 3x, I'm going to write this as 3 square x square. And because this 3 square in the denominator I have taken extra, so what I am going to do is I'm going to also multiply this by 3 square. Any questions on this step?
No, sir.
Okay, so now what I am going to do is twice limit x tends to 0 sine 3x divided by 3x square into 9, right? Now
Yes,
9 is
sir.
a constant. I can take 9 out. So that means this becomes 2 into 9. Limit x tends to 0. Uh, Sine 3x by 3x square, right? Now we'll apply a theorem. If you remember that limit x tends to a, fx to the power of n. If you remember, I had given you this, is the same as writing limit x tends to 0, fx whole to the power of n, right? So what we are going to do here is 9 into 2 will become 18, and I'm going to take the limit within the square, right? Okay. Now
Yes,
see,
sir.
we have 3x here, but in the formula, what do we have? We have x here, right? So what we are going to do here is, as long as 3x is very close to 0, we can write this equal to 1. But there's one more step which I would like to do because this is an introductory sum. Okay. So I say let y is equal to 3x. Therefore, as x tends to 0, 3x, sorry, y tends to 0.
Yes, sir.
So therefore, what does this limit become? L is equal to 18 times. Now, if I change everything in terms of y, limit y tends to 0 sine y by y square. Now have I got a standard form? Now have I got this
Yes,
form?
sir.
Yes. Now I have got. So this becomes 18 into 1 square, which is equal to 18. So the value of this limit is 18. Okay.
Yes, sir.
Any question?
Sir,
Tell me.
sir, in the examination also we have to let also.
No, you can write directly, but because this is an introductory sum, I have given you these steps. Later on, I'm going to skip
Okay, sir.
these steps. Okay. So you can also skip
Okay,
in your
sir.
examination. Number 2,
Okay, sir.
L is equal to limit x tends to 0 sine square ax divided by sine square bx. Okay. So this limit can also be written as limit x tends to 0 sine ax by sine bx square, right? So now you can take everything within in the square, you can take within the limit, right? Sine ax by sine bx square, right? So now this becomes limit x tends to 0. So now let's work within the square, whatever is within the square. So you want to bring this to sine x by x form. So what we are going to do here is sine ax we have. So we're going to divide this by ax. And you have sine bx. So we are going to divide this also by bx, right? But what is extra that I am adding here? What is extra?
Sir, a squared x squared.
Why a square x square?
Sir, because we are, sir, it is in the whole square form now.
Yes, but in the denominator, I'm adding ax. So that means I need to multiply this by ax, right?
Oh,
And here I
yes,
am
sir. Yes,
multiplying this by bx. So I need to divide this by bx. Clear?
yes, sir.
Okay, was all within this. That means what I'll do here is I'll put a bracket here because all this was within the square. Okay, so now what I'm going to do, I'm going to distribute this limit over the numerator as well as the denominator. So limit x tends to 0 sine ax by ax divided by limit x tends to 0, sine bx by bx into, and here x and x will cancel. So you're only left with a by b, right? So a by b whole square, that means this is a square by b square. So I can take this a square by b square out of this limit, a square by b square. And what am I left with? Limit x tends to 0, sine ax by ax divided by limit x tends to 0, sine bx by bx. All this square. Clear with this step? A square by b square. And this is 1 and this is also 1, right? I'm not substituting y is equal to ax or z is equal to bx. I hope till this part it is clear, right?
Yes, sir.
Which is equal to a square by b square. And that should be your answer. Okay. So that is it. I'll stop here.